Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of object-oriented software engineering. We'll dive into key concepts like class diagram, behavioral modeling, interaction diagram, state chart diagram, implementation diagram, component and deployment diagram. Let's get started. Slide 1. Class diagram. A class diagram is a fundamental part of UML and object-oriented design. It represents the static structure of a system, showing classes, their attributes, methods, and relationships. Depicts classes and their relationships. This helps in understanding how different entities interact within a system. Attributes represent the data members of a class. Methods, operations, define behaviors or functionalities a class can perform. Relationships. Association. A simple link between two classes, e.g., a student enrolls in a course. Inheritance, generalization. A child class acquires properties of a parent class, e.g., dog inherits from animal. Aggregation and composition defines whole-part relationships, e.g., a car has wheels, but wheels can exist separately, aggregation, while a house and its rooms are inseparable, composition. Significance. Class diagrams help developers visualize and structure software components, ensuring better code organization and maintainability. Slide 2. Behavioral modeling. Behavioral modeling in UML focuses on how objects interact and behave in response to events. It includes various diagrams. Use case diagram shows interactions between actors and the system. Sequence diagram depicts object interactions over time. State chart diagram represents object states and transitions. Key aspects. Helps in understanding system behavior before implementation. Defines how different parts of the system work together. Ensures clear communication between developers and stakeholders. Example. For an online shopping system, behavioral modeling helps define how a user places an order, how the system processes it, and how payment is handled. Slide 4. State chart diagram. A state chart diagram describes how an object transitions between states in response to events. Key components, states, represent different stages of an object, e.g., an order can be pending, shipped, or delivered. Transitions define how an object moves from one state to another based on events. Initial and final states indicate where the object's life cycle starts and ends. Example. A traffic light system has states, red, yellow, green. Events, time delay, pedestrian button press, trigger transitions. Significance. State chart diagrams help developers model life cycles of objects, especially in event-driven applications like workflow management, embedded systems, and process automation. Slide 5. Implementation diagram. Implementation diagrams focus on the physical structure of a system and how software components are deployed. Types. Component diagram represents software components and dependencies. Deployment diagram shows hardware configurations and software execution environments. Component diagram features modules, libraries, and executables. Dependencies between components. Deployment diagram features physical nodes, servers, devices, networks. Software artifacts deployed on nodes. Example. For a web application, a deployment diagram can show a web server hosting the UI, a database server storing information, a mobile client interacting with the backend. Significance. These diagrams are crucial for system architects and DevOps teams to ensure efficient deployment and scalability. Slide 6. Component and deployment diagram. Component diagram shows how software components interact. Defines modularity and reusability. Deployment diagram illustrates physical setup of a system. Helps in planning infrastructure. Example. For a banking system, component diagrams can show a user interface component interacting with a backend server. A security module handling authentication. Significance: these diagrams ensure clear software structure, maintainability, and efficient system deployment.